my YouTube viewers. Crystal here. I got up early this morning because I was expecting some money to come into my bank account, and then I realized it was the wrong day. So I'm up, and so I decided I was going to go ahead and make a video that I was intending to make. And I guess the name of this video is going to be something like what happened when I put the JetRail dataset into random forest regressor model. That's what this is about. This is JetRail is a time series dataset, and it had been put on stats models before. I mean, I personally didn't put it on stats models, but I got a computer program where it had been put on stats models, and basically because I personally didn't make that program or didn't have anything to do with making that program, I couldn't use the stats models algorithm because it wasn't my algorithm to use. So what I decided to do was I decided to put the data set onto the random forest algorithm because I was looking at a blog from Jason Brownlee, and Jason Brownlee said that you can use random forest for a time series analysis. So I thought, well, let's see what happens. So here we have the competition question with analytics VidHaya with the JetRail datasets, and this is the problem statement. Welcome, data hacker. Congratulations on your new job. This time you are helping out unicorn investors with your data hacking skills. They are considering making an investment in a new form of transportation, JetRail. JetRail uses jet propulsion technology to run rails and move people at a high speed. While JetRail has mastered the technology and they hold the patent for their product, the investment would only make sense if they can get more than 1 million worth of users within next 18 months. You need to help unicorn investors with the decision. They usually invest in B2C startups less than 4 years old looking for pre-series A funding. In order to help unicorn investors in their decision, you need to forecast the traffic on JetRail for the next 7 months. You are provided with traffic data of JetRail since inception in the test file. And then so the evaluation metric was RMSE. So this file is actually on my GitHub account. So it's under the JetRail TS repository. So you're more than welcome to find this file, TS JetRail Random Forest, and open it up and follow along with me if you want to. And so this is my own algorithm. So you're more than welcome to use it because it's a good algorithm, but it's not a winning algorithm. We'll just put it that way. So the first thing we did was we loaded our pandas and our NumPy file, which are two files that you pretty much standard that you need to load whenever you are working on a Python program. And then we loaded our data sets. You had 3 data sets. You had the test, train, and sample. So basically, we use the data frame and test and sample files. And I put data frame in this instance because I had used it in the algorithm that I had made, and I used data frame, so I thought, well, I'll just stick with convention and use data frame. So here's our data frame. We have all the dates and ID and account, and then we test file. Have our sample file, which is just the ID and the count. And what we did is we import matplotlib, biplot, and we make a graph of make a graph of this time series. And so you can see that the business started out really small and it's getting more and more customers. And then so since there were no negative values, we were able to put a graph on both sides, a two-side view. So if you want to see a two-side view, you can see that it started out really small and then it built up to get more users. Then what we did was we defined our X and our Y values. So X is DF dot X factorize 0, reshape -1, 1, and X test equals SX test index factorize 0, reshape -1, 1, and Y is DF count values. And then what we have done is we split our data set up for testing and training. So X train, X val, Y train, Y val equals train test split. XY test size is 30%. Random state is 0. And then what I wanted to do was I wanted to check the shapes of all the data sets that were created. And then what we did is we selected a model. So we selected our linear regression model. So when we put those X train, Y train into the linear regression model, we had 61.46% accuracy. And when we predicted on the X val, we had a 59.71% accuracy. We checked our RMS, and it was a 97.51. And when you're working with RMS, you want the file to be as small as possible, or the number to be as small as possible. So we started out with 97.51. Got the data frame where we compared the actual values with the predicted values, and we plotted it. So you can see it's not a very good plot, but that's our plot. We predicted on the X test, and you can see that it had some negative values on the X test. So that means that this was not really a good model to use if it had negative values, because it shouldn't have any negative values. Created our data frame, and you can see in the data frame that it had negative values. And so this is not a good model to use for time series analysis, but I just plugged it in there as an example just to see what would happen. The next thing we put it on random forest. So when we put it on the X train, Y train, we got 99.25% accuracy, which is very good. When we predicted on the X val, we got a 94.41% accuracy. And when we put it on the RMS, we've got 36.33, which is a definite decrease. So that means it's improved. We put our prediction on a data frame so you can compare the actual value against the predicted value by the graph. And so you can see that the black graph that we have plotted turns out a lot better than the graph that was plotted on linear regression. We tested it on X test, and we made a data frame so you can see the output of the data frame, and that's what we submitted to Analytics VidHaya. When I submitted it to Analytics VidHaya, we've got a 653. So, but that wasn't my lowest score. My lowest score was 333. And if you look on the leaderboard, which I know you can't see this, but if you look on the leaderboard, the best score was 132. So my score on random forest isn't anywhere near the best score. but this just illustrates that you can put a time series problem on random forest and it will work, even though it won't work very well. And that's what Jason Brownlee put in his site. He said that you have to make the file stationary and you have to make it a supervised learning file before it will work. But I just used the algorithm that I already had and the JetRail data frame in there. Then we checked ADA regressor because that was a model that I had a lot of success with. ADA regressor, when we put it on the model, we had 68.02% accuracy on X train, Y train, and 66.75% accuracy when we predicted on it. So we made a little data frame so you can compare the predicted values against the real values. And the RMS is 88.58, so you can see that it's a definite increase. So that means this is not the best model that you can use. We plotted the graph and you can see that the predicted values, we'll say, you can see that the predicted values are a lot higher than real values. We predicted it on X test and we put it on a data frame, and you can see again that the counts are not good, so this is not a good model to use. The next thing that we did was we put the model into a bagging regressor, and we got a 99.25% accuracy when we put it on X train, Y train. When we predicted it on X, we got a 94.40% accuracy. So that was definitely an improvement. And there was actually a very small variation between random forest and bagging regressor, but random forest still scored just slightly better. On RMS, we had 36, so that was a definite improvement. And we created a data frame so you can check the actual values against the real values. We plotted it on a chart, and so you can see that the actual values are similar to the predicted values. We put this on X test and we predicted on it, and you can see that the count was good. And also, because I didn't do it right, I should have said ADA. I had said ADA instead of bag, so that was a mistake that I made. So I'm going to have to go back into that file and change it to bag instead of ADA. Then we put it on polynomial regression. Polynomial regression 4th degree, we had a 68.5% accuracy on X train, Y train, and we had a 67.04% accuracy when we predicted on X val. When we put it on RMS, we had an 88, which was an increase from our 36. And then we made a data frame so you can look at the actual values against the predicted values. And then we put it on a chart and charted it, and you can see that the actual values are a lot different from the predicted values. So we predicted our X test on this, and you can see that the count wasn't very good, so this wasn't a very good model to use, which is always a good idea to, try to put it on a data frame and see what your values are. The next thing we did was we put it on a polynomial regression to the 10th degree, and we had a 67.89% accuracy on X train, Y train when we fitted it. And we had a 66.37% accuracy on X val when we predicted on it. We had an R of 89, which definitely was higher than our previous random forest score. So we put it on a data frame where you can check the actual values against the predicted values, and you can see that the predicted values for the most part are higher than the actual values, and you can see that on the chart that we have plotted. Predicted on their test set, and you see we've got the answers on the test set, and they're not very good. Now what we did is we put it on a polyfit. This was just polyfit was something on NumPy, and this was just to see what would happen, and it wasn't actually part of the model, but polyfit graphs charts as well, so I wanted to see that. So we put the data frame on this polyfit, and you can see what happened when we put it on the polyfit. And you can see that the data frame, it started out with not very many passengers, and as time went, I got more passengers. This is our analysis. It's not the same as stats models, but I just wanted to show you a different way to do it. And the stats models gave a more accurate reading, because when we were on stat models, and I know you can't see it, and we put it under Serapmix, we had a reading of 333, which was a low-ish reading, but the reading that we got for random forest was 653. So the reading on random forest was double the reading on stats models. But this was just an example to show you that it's another way to do it. And if you have a small time series data set, you can always put the small time series data set in this algorithm and see what you get. So that concludes it for this presentation. If you like my presentation, please like, subscribe, and share. If you like the work I do and want to leave a donation, I've got my email address to my PayPal account. I don't have enough subscribers, so I can't monetize my account, and the only way I can make any money on my account is to make donations. Ask for donations. So thank you so much for watching my video, and I look forward to making new videos for you as well.